So, before starting this topic, which is having a weightage of 3 to 5 marks in GATE, so let me know what is the status of your knowledge about these things. So, have you guys ever already studied this, or you are completely new to this topic?
Sir, already had studied, sir. Studied, sir, already.
Okay,
Studied, sir.
you can directly put in chat. Studied means yes, sir. If not, no, you can put. Okay, okay, okay. Yeah, fine. That is fine. I see majority of already studied this topic. So I will not go into detail. I will just uh, 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 take this session in an interactive way. So I will be asking. So you have already studied. So yeah, that's fine. So I will ask some of the questions before directly going into the topic. I'll just introduce. Then we'll go on solving some of the questions. So this was the main theme. Like it's practically impossible to manufacture or produce anything exact irrespective of methods of manufacturing. So why we cannot produce exact? Can someone? Okay, wait. Krish Karti, can you mute yourself? Yeah, thanks. So this was the basic saying. So we cannot produce any shape or any product exactly same twice or thrice. We may produce or we may not do, but this is the thing that's the whole concept of this metrology or any inspection that we see in daily life. So why we cannot produce, I will discuss in the next things. Then come to the inspection. So as you know, there are two types of inspection that we generally follow based upon the product, you can say. So if the product is producing continuously with very high rate, so there are basically two types of inspection. Can anyone say what are the basic two types of inspections? Broad classification.
For mass production, gauges are used, sir.
Okay, but any other comments? You can just type in chat box if you're. Okay, so that answer is like mass production. This is the types of productions you can say. Okay, mass production, job production, or batch production. But this is completely related to inspection. So while producing these mass or batch, whatever, how will you inspect them? Look at visual inspection. Nice. So dye penetration testing, non-destructive techniques. It's not. It's a broad classification. Not. It's not that much difficult. Anything that you can remember, but by these two, offline or online?
Yes, sir.
Yeah.
During the online inspection means during the work in the progress, sir.
Okay.
After the job production, that inspection called offline inspection.
Okay.
For online inspection, the machine vision, that softwares are used.
Okay. Yeah, that's it. So so there is yeah, that's the exact definition. So in online inspection, you can directly while producing itself, you can see if there is any deviation, if so ever, we can directly change the parameters accordingly, and we can get the exact shape. So in offline inspection, so we cannot change because everything is already produced. So only you can avoid the things, avoid the bad products. Only the good products you can utilize. So by this definition, you can see in online the wastage of product is less, whereas in offline we have so much of wastage. But at the same time, we have to see the economical aspects also. So we cannot inspect if the production, suppose if I am producing a small screws or nuts or bolts, which are of very low quality, means low cost, you can say. So every time I cannot go and measure because inspection cost is high compared to the unit price. So in that case, I will go for offline inspection. I will produce a batch. I will see how it is going. If it is not, I will change the parameters later. Okay. So well, if there is any interesting product, say if you're producing an engine block itself, okay. So now it's the that product is itself very costly. So you have to go for online because you cannot uh, lose that much of money if you follow offline. Okay, regarding this online, so you also heard about this industry 4.0 or a digital twin. So there are so many new technologies that is being developed, so that online, so the machines is itself communicating themselves, and then they change parameters themselves. So there is no interference of man. So these are basic offline and online inspection and their advantages. So this theory you should know. If there is any theory question for 1 more, you can easily you know uh, gain marks. So this is an interesting say interview questions rather than gate questions. So there is what is accuracy and precision. So I will not ask. I will just draw some diagrams, and you can just make out which is accurate and which is precision. So I will give an example in this. Say, so everyone during college times. So if there is any class at 8 o'clock sharp, so you see some people will come early, some people will come exactly on time, some people come late. Okay, so I have collected the data of these things for say 1 month, and I am just plotting for individual students. Okay, so say some 4 or 5 students are there, and I will just show the data here, and you say who is accurate and who is precise. Okay. So I'm just plotting a type of pie chart. So this thickness is 1 hour. Okay. So there is say I took some 4 students. I'm plotting each student's data. Say A, B, C, and D. Okay. So this correspond to say some 8 o'clock, and this correspond to 9 o'clock. So my this is the on time, and this is early, too early. You can say. You can. I'm just taking a example. So let's say option A. So in 30 days, so this is where he lies. So in option B, so like student B, this is where he lies. Option C, so this is how he is going. Okay. I just need 3 students. So now the first thing is which student is accurate, which student is precise, and which is not accurate nor precise. I can take four one also. He's not accurate but precise.
A is not accurate but precise.
So let me ask. So who is accurate? You can put your answer in ABC in chat. Sorry, this diagram lies here. This point lies here. Okay. So I get option A. I'm repeating the question. Who is accurate in this case? Just accurate. I'm not concerned about precise. Okay. So who is precise then? Okay. Okay. Who is neither precise nor accurate? Okay, I think this everyone answered. So there are some students who can get this concept. Yeah, I think everyone is clear about neither precise nor accurate. So that is the student C. So I mentioned. So 9 o'clock is the exact the correct time. Okay, and 8 o'clock is too early. So first question is who is accurate? So accurate. I'll just give some definitions before going to the. Okay. So accurate is so the student who is exactly sticking to the time 9, whether he might be exactly 9 every day, exactly 9, and precise is like so he is sticking to some time between 8 to 9, say some 8:30, and he comes exactly at 8:30. Okay, norm is his wish, like he can come at any time, nor accurate nor precise, whatever. So the first question is accurate. So 9 o'clock. So if you see option this student D, so every time he is coming at 9 o'clock only. So that is what the exact time, and he is coming every time. So this option D is like he is accurate as well as he is precise. So precision is something to do with the repeatability. Okay, so he is repeating the same thing, and accuracy is something to relate to the exact time. So option D is like he is both precise and accurate. So now if you come to the option A, so he is not accurate, you can say, but he is precise. He is coming to some time and he is sticking to that. Now if you see option B, he is also precise because he is also sticking to some time, and he's coming, means that points are lying in this. But if you come to the C, he's not sticking to the time, that is 9 o'clock, and he is not sticking to a time, and that's it. So I took a some random example. I think you guys got the concept. So if interviewer asks, so this is very confusing when you are in an interview panel, interview say. So accuracy or precision, how to remember this thing? Okay. So see, accuracy is something to do with, but it is something that everyone cannot achieve. So try to be precise. So you should be precise. So so if you want to answer any question, you should be precise. You should not answer everything. So that word people use very frequently. So try to be precise. You may not be accurate, but try to be precise. That is your repeatability, your dedication, you can say. In such way you can remember. So one thing is to you cannot reach accuracy every time. Okay, but you can be precise. Okay, just you can you don't have to follow this, but you can remember in such a way so that you cannot get that confusion during that time. Okay, there were some questions regarding these two also, uh, so that's why I spent some good amount of time on this concept. Okay, let's move. So while starting, I just started with one statement that we cannot produce the same product irrespective of the method or the machine. Okay, so why so? Uh, so can anyone tell why we cannot produce? What are the factors that influence? Suppose I'll just take a very small example. Okay, I just took a hexagonal bolt. Okay, so there are some factors that involve in producing this bolt. So can anyone tell what are those three factors?
Operator errors,
Okay,
material properties may be constraints,
okay, one more.
atmospheric effects may be also constrained.
Okay, any other?
Static to the operator.
Oh, that is already covered. Operator, fine. Everything comes under it.
Mission errors, sir.
Okay, there are only three. I think you already answered. Let others. Okay. So this is like 3M principle, you can say. So one is, as I said, as also said by one of the students. So one is the, let us start with the material. Okay. So we cannot produce 100% homogeneous material. Then once the material is available, then I will take it to a machine which will have some wear, errors, whatever. The third one is the main one who is operating it. The main thing you have to concern about is the skills. Okay, so this is like, you can say, an infinite universe, and anything that is coming out of this is in a random variable, a random data. So, and which follows a normal distribution, of course, which we'll cover later. So these are the three important factors that influence the production of any product, uh, and which directly changes the exactness of this any product. So these three, so material, I said inhomogeneity, and so if you product one product and if you go to the next, the material might change. The machine, so they're complete compulsory, you have to use any gears which will wear out, of course, and there will be some errors and there will be some breakdowns, and so these are the certain errors that are involving, which changes the product capabilities, and that is why you cannot produce an exact same product twice. Okay, So why we are learning, so what, we are we are not getting, so we are not getting the exact shape, so why to bother? So now, suppose if I say, if I want to produce, I will not care about all these three. Suppose if an industry guy comes, I don't want to care about this. You buy, you make a material which is homogeneous to the extent machine, very nice machine, very costly machine, and men all the skilled people you use. So what happens is that the cost, production cost goes too high, such that the industry cannot sustain. So that's why these industry people, what they do, they give some tolerance. Okay, so if I want to produce so same hexagonal bolt, I will say some 8 mm hexagonal bolt I want. I will give his some say 0.001. So this is the tolerance I will give. So the maximum allowance that product can be produced. So if you see here, so it can go, uh, so this is the range. Okay, this is the range I can produce a nut. So now I have the freedom to produce the this type of products within this range. So I don't have to worry much, even though all these factor influencing. So I don't have to worry. So this is the concept that came into picture, so that the tolerance has this much importance, so that we can avoid all these errors, and we can use this type of production everywhere while designing. Everywhere we can take these readings and we can proceed further. Okay, this is the concept of this 3M and this randomness in the data. So now comes to the assemblies. So so before this, I will discuss later what are the types of assemblies and why we need it. So we have basically three types of assemblies. Can anyone remember? You can put in chat. Assemblies, so let me give an example. Suppose if you want same, the screw I have taken, I will manufacture bolt I have taken, and I will take a nut, and I will join both of them. So I can produce these things in different types. uh, so that was the product I want to produce. So what are the types of assemblies? This is the sort of assembly I'm talking about. So what are the types of assemblies I can use to make this product, to make this assembly?
Temporary, temporary assembly, permanent,
Okay.
like welding, soldering, brazing, riveting.
Okay. And think in metrology aspect. That's the like types of joining. It's not into the manufacturing. Think in metrology point of view. So I'm not. I'm doing the same process. So I'm taking a screw. I'm taking a nut. I'm just assembling it. The process is same, but the assemblies, the production.
Yes, sir. Interchangeable assembly
Okay.
is selective
Yeah.
assembly and trial and error methods.
Okay. So any other? So I see transition interference. Yeah, we'll come to that. Yeah, as you said, so one is the interchangeable. Selective assembly. Make to suit. Okay. So how can you just I can make a simple definition. So as you go from top to bottom, means interchangeable selective and make to suit assembly, the tolerance I am providing will decrease. So in interchangeable assembly, I have a tolerance. I have this width of tolerance. So as I discussed previously, that 8 plus or minus 0.001. So this 0.001, if I see 2, so this range will decrease as I go from top to bottom. So interchangeable, selective, and make to suit assembly. So in this, so let me come from top. So what is the interchangeable assembly? So as I said earlier, this data will follow this normal distribution with a mu at the center. Let me take a product. So this is the range I am talking about. This range. Let me say take some ABCD. This is one lot produced somewhere else, and this is lot 2 produced somewhere else. So this mu can vary. So from lot 1 I will take the bolt, from lot 2 I will take the nut. Okay. Now in interchangeable assembly, what happens is that I can take so in this I can take A, B, or C, or D, anywhere. I will take the bolt and I will take any nut from the C or D, and I will make the assembly. So I'm not bothered about whether it will fit or whether it has a different types of tolerances, like someone is saying interference, transition, clearance, whatever. I will not bother. I will take some lot bolt from one lot, and I will take nut from one lot. I will make an assembly. So this is like interchangeable assembly, so which can be used universally. Uh, okay, suppose the best example coming to my mind right now is the this holder for the bulb. So suppose if there is any gold medal company is making the holder for the bulb, that bulb socket. If you think and if you buy any Philips lamp, you can easily fit into it. So interchangeable assembly kind of. So this is anywhere you can use. And but in selective assembly, what happens is that you have to use the lot should now we will have a again distribution here. So now the tolerance has decreased from this much range to this range. Now I have to take a bolt from this lot A, and I have to take the nut from this lot, the small a, not from the other lots. Okay, so this range is decreased in when you come to the selective assembly. Now when you come to the this make to suit assembly, so now this even decreases. Now in the make to suit assemblies, I will have a shaft. So now in make to suit assembly, I already have the shaft, and now I will make the according to that shaft I will make the any hole. Okay, so now I'm discussing shaft and hole. So this can be any type of feature. An internal feature, we can say a hole, and an external feature can be of any shape which can be termed as a shaft. Okay, these are the different types of assemblies that are generally discussed. So now coming to the important topic. So whatever I've discussed is it's like a prerequisite for this you know this topic. But this limits fundamental deviation is the like the main topic which was frequently asked in GATE. Okay, you can revise this before going to exam, which will fetch you good marks. So before going to this, can you even tell what are the limits or what is a fundamental deviation? You can put in chat box and you can speak. So what is a fundamental deviation? What is limits? Okay.
The deviation from basic size.
Okay. So where do we need this fundamental deviation? Did anyone remember the formula for fundamental deviation? Don't you remember? It will be provided in GATE, but
Yes, sir.
okay.
Fundamentally, I means 0.45 cube root of d
Yeah,
plus.
yeah, correct, correct. So what is the definition of this fundamental deviation? That is the formula we use to calculate fundamental deviation. Okay, so everything deals with not a single type, say whole or so this fundamental deviation. If you wanted the definition, it is the difference between maximum material limits, say hole or shaft. The maximum material limit is the fundamental deviation. Okay, and the limits is something somebody already said the maximum minimum of a given value. Okay, now what is the tolerance?
Permissible variation in the size of the component
Okay.
from its basic size.
Yes, yes, is the permissible variation. So if you see there are some so if you see any gate question related, you see something like this. Okay, this so in this so before going to that, can anyone tell me what is a basic size?
26.
26.
Basic size is 26.
26.
What is the nominal size? Yeah, you said
Sir,
correct. This is the basic
What are
size.
the same, sir?
sir, I have not understood fundamental deviation. Please, will you
Yeah, yeah, yeah,
repeat?
yeah. I'm going to that. I just gave a simple definition, but I will repeat it again. So let us discuss this. What is the basic size and what is the nominal size? I will write a values. You just say. So I wrote a 4 values. Which value do you think is a nominal and which value do you think basic size?
Twenty-six basic size.
Okay. What is 26.00100 or 26.02? Okay, I will just. It's a very simple thing. Just don't be confused with this. So nominal size is something you round off. Say if I have 26.001, I will write 26. That is the nominal size. Basic size is the value that was given to you by the industry person. So now this basic size can be a nominal size sometimes. Okay, but not the vice versa. Nominal size never be a basic size, but basic size sometimes can be a nominal size. As you can see here, 26. It is basic as well as nominal. Yeah, understood.
Yes, sir.
So okay, I think let us discuss the theory part. Then from next class onwards, I will. There are some numericals. Let us see if anyone can solve it because we have very limited time, like 20 minutes. Say. We'll discuss this problem. If you can solve, this will be easy for me to teach also. So I just take a break from this discussion and just try to read the question and try to answer it. This was the previous gate question.
These are options.
Okay, nice. Okay, nice. We'll wait for another 2 minutes. That's solve it.
Sir,
Yes, yes.
this is the first class on the meteorology. Or second class, sir.
This is the first class.
Last class, what was it?
So last class is something to do with the casting types and some of the defects. So there is a session going on casting as well, which will not cover these topics. Say different types of castings and defects in castings.
What is on Wednesday, sir?
Yeah, this Wednesday. Okay, I see so many answering the questions. 0.012. That is not there in option. Yeah. So let me answer this question. Before that, so you should know how to so this fundamental deviation, everything I will just discuss. If you see any question like this, as I said, so I'll take the values from this. So there is 25 point plus or minus 0.04, 0.02. Okay. Okay, this is the notation they have given. And this is for the whole. Okay. So if when you see this type of questions and when they are asking any whatever types of clearances, interference, and any values they are asking, so first thing you have to do is just draw a horizontal line, which is the basic size. Here it is 25. Okay, you don't have to remember that. Just draw a horizontal line. That is the 25. Now, so this pin diameter, which is the shaft, is 25.0005 and 008. Correct me if I'm doing any wrong in this, the values. So this is the shaft that they are given. So in the first step is draw a horizontal line, which is the basic size. Then you place the things. So you have given 25 plus or minus 0.02. So generally, so now, so the maximum it can go is tolerance is 0.002. Okay, now say this is the whole 02. Okay, then you place the shaft as well. I'm placing a distance so that it will be easy for me to calculate. Okay, this is also on plus side, but uh, okay, just a second. Okay, this is the whole.
Sir, if both are positive, we place them on the same side.
Yes, what both are positive.
If both the allowances are positive, we place them on the same side. Also.
Yes, yes, above the basic size. So this is the basic size 25. So both are positive. So I am placing everything on the top. So this decides positive or negative. So now the minimum if we have is 0.005 and here 0.008. Okay. Now if you see the question they are asking, assembly interchange with the pins and diamond, the minimum clearance in the assembly will be. You can easily make out what is the clearance now. Can I say this as a clearance?
Yes, sir. So this value is 0.012.
Okay.
I was only getting this.
Yeah, yeah, correct. That's why I'm asking. Can I say this as a clearance? Any other? Or can I say this as a clearance?
Yes, sir.
Now we have two clearances then. But what they're asking in the question? The minimum clearance in the assembly. So when the minimum clearance comes,
When both has a maximum material limit.
When tolerance zones never meet, sir.
tolerance.
Zone don't meet the value.
So previous whoever said that is the correct one. So when both have the maximum material limits. So what value are you getting if you do what is the value of this clearance?
0.012.
What is the value of this?
0.015. Sir, what to do now?
Yeah, I think there is a wrong option. It seems minimum clearance they have asked. So we have two clearances. One is 0.002 and one is the 0.015.
Sir, is there any difference when shaft का जो maximum और minimum 0.005 और 0.008 को interchange कर देंगे तो?
What can you repeat?
Sir, is it will make any difference if we write 0.005 above 0.008 in the?
No, it doesn't make any difference.
Sir, why we are considering 0.015 as a clearance, sir?
Yeah, that is what I am also wondering, because that is the maximum clearance.
No sir, maximum clearance तो 0.035 हो जाएगा.
Yes, that's true. This is the maximum clearance. Just a second. Yeah.
Sir, RJ by mistake gave it as plus 0.008 instead of minus.
This one. But how people are getting value of 0.015?
That's what's actually in the question. It is minus 0.008.
Okay. Okay. So that makes sense. It's a bilateral tolerance. This is correct.
Yes.
But still, this is the minimum clearance, right?
Yes sir.
Which is
0.008 has gone on the other side, so the clearance will increase.
okay,
Sorry.
0.02 minus 0.005. How much you are getting?
0.015.
Okay. Yeah. Yeah. Thanks for pointing out that mistake. Okay. So there was one more numerical. If you're interested, you can try this.
B sir.
Mm, let's wait.
20, sir.
20 सर। सर 30 वाले को रिमूव कर दीजिए।
Okay. Everyone is getting the same value 20. Just solve it. Well, I will just write the total nomenclature of this. If anyone is noting down, you can note down. Okay, everyone got the same answer, 20 microns. Any doubts? Okay, so let us end with this beautiful diagram on fundamental deviation. So someone asked earlier also, what is the fundamental deviation? As I said, it is the difference between the maximum material limits, and also the basic definition is how far from the basic size the tolerance zone is located. So as you see, this is the tolerance zone which was located this far. So that is the fundamental deviation for the hole, and this is the fundamental deviation for the shaft. Okay, and we have this is the lower limit, those who are wondering, and this is the upper limit, which is also called E cart superior and E cart inferior, and as well as for the shaft, same thing will follow. Okay, this is the diagram that should come to your mind whenever there is asking questions such type of questions that we just saw. And also, if you see that limits and types of fits, that will be covered in next session, which was an easy topic, and you should keep in mind there was very nice question I will solve in the next lecture. So as you know, there are three types of, someone also pointed out earlier, there are three types of fits. As I see, clearance fit, we have seen now, as well as interference fit, and as well as transition fits. Okay, so these three types of fits will come to know when you draw this diagram for a particular system. Okay, now we have a this one diagram. So as you see, earlier I have wrote like something like this. So what is this G and what is this G? So that is one sort of notations that we write for this fundamental deviation. So we have so I will discuss in the next class. So before that, you can just have a look about this fundamental deviation, like how the things are done. So there was a notation for this, like this, like how far from it is situated, and it will come, and H will sit here, which has a 0 fundamental deviation. Don't think only alphabets will come. There will be a special notation like this, and end with Z. This is the for whole. We are using capital. If you see, capital letters for whole. For shafts, we use small letters. Okay, this is the diagram. No need to remember, but from this diagram we can easily come to know that. So this is from A to say H, or whatever the shaft which from A to C, or before this if I take Z. So this category and this category, it is always having clearance fit. Okay, if there is any question, if you can remember this, if there is any question saying capital A and small a, you can directly go for this, this clearance fit. Every time it has a clearance fit, and after this you have an interference fit, because this shaft is every time it is higher than the maximum material limit of the hole. And you remember this capital H is always having 0 fundamental deviation. So whenever you see a question with any, say, capital H, so say this is the thing they have given, so immediately you can directly place it here. So you don't have to wonder about where is the fundamental deviation. It's always 0, if you see capital H, and if you see G, which was below, it is always having a clearance fit. So that is what some of the takeaways from this diagram you can see. Okay, next time in the next class I will discuss these types of international tolerances, and solve what is the formula for this fundamental deviation, how it was derived, and I will solve some of the questions related to that. Okay, then we
So
can
these
go.
numbers,
Sorry.
these numbers 6 and 7.
Yeah, that's what these are that's those international tolerances, IT values. According to this, we have to, so we have some corresponding values to which we have to multiply the fundamental deviation. Should be multiplied by the, not the 7, but we will have some values for this, some 69, something like that. I will discuss everything in the next class. I just give an small picture so you can think about. Okay, before coming to class next, you just have to have a look about this, then you can easily get the things in the next class. Okay.
Sir, there is capital H 6 instead of small g. If there is small h, then it will it be interference or means any remaining type, no?
If there is capital H,
And instead of small g, there is a small h.
small h.
Hmm.
Yeah,
Then it will be the one of the remaining two types of hits, no?
it, yes, it will not, it cannot be interference fit, because you see the lower maximum metal limit of hole and the maximum limit of minimum metal limit of hole shaft. Okay, so they are not interfering
Okay, sir. And in previous
like here.
diagram,
And
uh, can we go to previous slide?
this one.
No, no, that red. Yes. In
Yes.
this fundamental deviation above the BS is for FD of whole. Na?
I'm not getting that shortcut you are using.
Fundamental deviation of shaft you have written below BS. In the
Yes,
similar manner, the upper part will be for fundamental deviation of whole.
yes, yes, of course.
Okay.
Correct.